Okay guys, I'm back at the Glen Sebastian Nature Trail once again for the second week in a row. This week's lab is going to be a lab that I actually get really excited about every year, and you guys have reaped the benefits of this lab. In this lab, what we're going to do is we're going to install another piezometer or a groundwater well out here for us to use for future years. Now usually I'd have each group install one, and I figured what I'd do this year is I'd just install one for us and you guys can all come and visit this. It will be well number 15, okay? So the idea behind installing a groundwater well or a piezometer is actually pretty simple. All we need to do is we need to excavate a hole down to the water table, and in fact past the water table. Keep that hole open long enough for us to insert our well. So how do we do that? Okay, well, there's a number of different ways that we can drill a hole. You can get pretty simple, you can get pretty complex, as it turns out. One of the simplest methods would be to do what we're going to do today together, and that is called using a hand auger. So a hand auger is basically, imagine if you could blend together a shovel and a drill into one, and that's what a hand auger is. Essentially an auger means a drill, but there's something special about this hand auger. So let me show you the business end of our hand auger. This is what will do the digging for us, okay? This is an auger and a basket up above it, so you can see we have these sharp teeth right here. There's two teeth right there, and when I spin this righty-tighty, right direction, these teeth will cut the dirt away and they'll actually scoop it into this basket right here. So again, this does the digging just like a shovel, and it does the storing just like a bucket, okay? So we can pull that dirt out of the hole, we can dump it off to the side. We do that over and over and over again. Now, hand augers are pretty useful. I used to use them a lot in my work. We'd use them for environmental sampling if we want to quickly take a soil sample, if we want to install a temporary monitoring well. This is the way we're probably going to do it in this area, but there are limitations. There's really only so deep you can go. As you'll see, this is a manual method where I'm going to be turning a handle. Okay, so there's a set of rods here. I actually bought some new rods for you guys that we're going to use today. But essentially, this handle will screw onto a rod and we'll spin this by hand. So after you reach about, I don't know, an hour or so of turning, you're going to get pretty tired. As you go deeper and deeper, we're going to have to add more and more rods, as you'll see, and this thing can get really difficult and slow to use. Once you get beyond about 10 feet or so, that's kind of the limit. Back to the auger, one thing I wanted to show you guys is that there are different attachments. There are different augers for different purposes. Not all of these are made the same. I've got actually 3 of them in our kit. The first one that I showed you, this is your all-purpose auger, okay? It's going to be good for when you're dealing with loam, so a mixture of sand, silt, and clay, or maybe compacted sediment, something that's going to cut very easily and stay together and not slide out through this opening in the bottom where those two cutting blades are. So this is your all-purpose. This is what I'm going to start with. This is what I use probably 80% of the time. Now, there are specialized attachments here beyond the all-purpose. I've got 2 here, and you can kind of see the difference. All right, I'll start with the one on my left, on your right. This is called a sand auger, and it looks a lot like the all-purpose auger, but there is one difference. You can see those cutting shoes are much closer together in the sand auger versus the all-purpose. And the reason for that is, if you're working with really loose sand, you cut it away. If you try to pull it out with the all-purpose auger, that sand's just going to fall out of the bottom. So it can become very difficult to drill in sand, and that's not something that's exclusive to the hand auger. It's difficult to drill in sand anywhere you go because it continues to collapse in, even if you can get it out of the hole. So hopefully we'll avoid just that really loose, almost think like beach sand. This is the only auger that you're going to be able to get away with in that situation. Now the other specialized auger, very different than the all-purpose auger. The cutting blades are actually a little bit wider here, and you have this window in your basket, okay? This one is actually a lifesaver. I've used this a time or two and I'm glad I have it. This is for drilling into clay. Now when we hit clay, clay, as you know, is very, when you did the texture by feel, clay is very sticky, it's very cohesive. So it likes to clump up, okay? So if you drill with the all-purpose or the sand, well, the sand's probably not even gonna get you much of that clay, but if you get into some clay with the all-purpose, what's gonna happen is that clay is gonna get stuck inside of this basket. And you can try and beat it from above, you can try and dig with your hands, you can do all number of things. It's very difficult to empty this basket when it's full of that sticky clay. I've been stuck in situations where I used to work, we didn't have a clay basket, and you maybe get a screwdriver and try and loosen it out and just enough to get it sliding. It's very difficult, it takes so much time. So the clay attachment is really useful. It's simple. This fills up with clay. Just pop your hand through there and you can actually push it out. So you have this nice window. It's really, really kind of useful. So that does the overview. I guess you'll see this in action. I'm basically going to have my auger screwed to a drilling rod, and then the drilling rod will be attached to our handle here. And I'm just going to screw this thing down in the ground until I hit water, and I'm going to keep going as deep as I can.
Spasm waiter dropping to his knees, sees slander on wrapped paper ties. Lifting up his head, he feels the sunlight in his eyes.
See how this works? Cutting teeth right here, fill up this basket. And there's no real sophisticated way of doing this other than just flip it over and dump. Start over again. me catch my breath for a second. I'm starting to see a little bit of water show up, sticking to the sides of the auger, and also I can tell this sand is kind of wet. It's got a, yeah, that's wet sands. So more than likely I'm near the capillary fringe, or I may even be underneath the water table itself and into the saturated zone. Now what's interesting about this, and I've seen this before out here at the Glen Sebastian Nature Trail, is this sand is really, really clean, coarse, almost like a quartz arenite sand. Thinking about it from an infiltration standpoint, this is what a lot of the citronella is made of. It's just sand, almost like what you'd use inside of a children's sandbox. So it's going to drain really quickly. Water's going to move pretty quickly through this. So I'm going to take a sample of this, and we'll be able to do a little bit of test to figure out how conductive this is for water, or what the hydraulic conductivity is. But there it is, the sand. Really, really good stuff. You know, a lot of people in Alabama will actually mine this and use it for an aggregate for concrete. Back to work. So I'm going to get a sample of this. Yeah, that's some good sand there. Real pretty stuff. Real pretty. Didn't take as long as I thought it would. One of these rods is 4 feet long, so I'm probably about, with the auger on the end of that, I'm probably about 9 feet deep or so. And one of the things you may have noticed on the last couple of drills, last couple buckets, is that I can pull out a lot, but I'm not getting any deeper. And so what's happening is I'm in completely saturated sand at this point. I'm in the zone of saturation. I'm below the water table. So when I dig that sand out and I dump it over here, by the time I get back to the well, that wet sand is almost like a gel. It just flows back into that hole. So yeah, I could keep digging and I'm going to pull out a lot of stuff, but I'm not getting any deeper. All that's happening is my hole is just caving in. So at this point, this is as far as the hand auger is probably going to let me go. Okay, so let me take a look and see if I can show you this hole that I've created. Show you the sand. Okay, so you guys can now see what I'm seeing. There's my hole right there. Always be careful when you're next to an open hole. No telling what sort of wedding ring or cell phone or car keys might fall down there. So I'm going to take a step back. Here's my auger. And maybe you can see in there, it's wet. This is very soupy stuff. Here's the sand that was coming out, and I mean, this really is some good sand. I've seen this before a couple times out here. This is kind of what you hit in the zone of saturation out here. Hydrogeologist that's looking for water. This is very good aquifer material. Very good aquifer material. And I took a sample of it, so we'll be able to look at the grain size. We'll be able to calculate what is called the hydraulic conductivity. Okay, so this pile right here, actually, I'll probably use this to backfill the well. Typically we use sand, and I did bring this out here by myself. This 50-pound bag of sand here. It's actually wet a little bit more, but this stuff in this bag is probably the same stuff that you're seeing laying down there on the ground. So next thing I'm going to do is I'm actually going to put this well in here. Actually, we'll do it together so you guys can take part in this. I wouldn't call this well 19, but it's going to be well 15. There we go, down the hole. I'm just going to drop it. Let's see if we can hear anything. Not really. Not really. I'm going to push it. Oh, there we go. Man, I did cut this at a good length. Okay, I'm pushing it down through that sand, and that's about as deep as it's going. Man, whew. It's just hard work. Really good exercise, though. So there we go. Our well is now in the hole. It's in the boring, but our construction is not complete. We've got all this space around the outside. All this space is what we call the annulus, or annular space, okay? And if you're producing a well, if you were going to use this for drinking water or something like that, you really wouldn't want to have this open space, because if something were to get on the ground that you don't want, some chemicals or some pet crap or something like that, it could get down to where your well is pulling water very quickly. So we're going to do what's called backfilling with this sand. Maybe I'll start with this nice sand as a filter pack, and then fill up above that with this cutting material, and then I'm going to finish it off with what's called a sanitary cap. I've got some concrete here in this bag that we'll add on top, just to keep things from creeping down the annulus. All right, so I'm going to go ahead and see how well we did. Pun always intended. Really doesn't matter if I go from the north side or not at this point. I'm just checking to see if there's water in here. Probably going to have to come out here with a PVC coupling and rise this up. Hear that sound? We did good. We got groundwater, and that is right at 7.00 feet. Lucky. Let me see how deep this well goes. We're at about 8.85. So there's 1.85 feet of water in there. You can see this thing's crying. It's really screaming. That water in there is kind of dirty. Typically, and you know what, maybe I'll do it. If you had a brand new well, it's going to pick up a lot of the material from your cuttings. It's going to be kind of silty at first, and so we'd go through the well development process, or we just pump water through there, try and get that silt out. And eventually the sand, or filter pack here, will serve as a filter. So if there's any fine material, any silt or clay or anything like that, if there's any silt or clay, it can get filtered in the pore throats of your sand. So the sand serves a purpose. It filters your water. If you've ever seen a swimming pool filter, that's how it works. And it'll keep your water nice and clear. Eventually that sand, though, can get kind of clogged up, and we can go through a redevelopment process where we pump water into the well and kind of blast that clay back out, and then we pump water back out to reinitiate the well. So let me start backfilling this. Take some of our sand. Okay, so about maybe a third of that bag. 20 or so pounds of sand. Next thing I'm going to do is I'm going to kind of spin this around, almost like I was making gumbo or etouffee. I'm going to spin it around, and that's going to help this filter pack material find its way down to the bottom of our annulus. It's very possible, especially if you're drilling a deep well, if you start filling your material in there, that it gets kind of stuck on the side, and you may think that you backfilled everything and have a huge pocket, which is not good. It's not a good thing to see. Okay, so I'm pretty happy with that. I wish I could see down there, but I can't. One last push and a turn. And now I'm going to start backfilling with our cuttings. A lot of times what we would do, and since I'm not using this for drinking water or anything, but what we may want to do is actually cover this sand, cover it with bentonite. Bentonite is that expansive clay. It's what's in kitty litter. And what bentonite does, if you've had cats before, is when it comes into contact with water, it expands. In fact, it will expand 200 to 300% of its original size. And because it's a clay, it kind of blocks the flow of water. So bentonite will serve as a well seal. So you have this seal that keeps water from leaking down the annulus from the surface and contaminating your well. So really important in terms of keeping your well nice and sanitary. All right, it's done a good job backfilling here. Used about probably, I don't know, maybe 50% of our cuttings. Man, really easy when you've got this nice sand to work with. I've drilled wells out here. You hit that clay, that sticky clay, you hit maybe a confining layer. That is hard work, hard work. Okay. So I backfilled this, and I'm going to actually excavate just a little ring around here. I would show you this, but my hands are filthy. You know, I had a rag, a jag rag, but I don't know what happened to it. There we go, not a big deal. So let's take a look at our nearly completed well. So we've backfilled around the annulus. Okay. So we have this little trench here, and I'm going to take that trench and I'm going to pour some concrete in there, and I'm going to pour an even amount of water. Not a whole lot. Really, this isn't so much of a sanitary seal as it is just something that's going to keep this well from moving, especially if somebody were to come mess around with it, then it's not going to give up so easily. I'm going to pour this water in there. Okay, and just kind of knead it with my hands. Try and mix that sand in there real good. That will serve as an aggregate. And that looks pretty good. Really not a whole lot to it if you think about it. There you go. That's a complete well here. So this will be ready for you guys to come check out when you can make it up on campus. I'm just over, just a little bit west of well number 11 or PZ11, and just a little north of PZ12. So it's gonna be hard to find until I put a riser on here, which I'll probably do over the next couple days, and put a flag next to it. But you guys did this, you took part in it, so this is your well, this is your class as well. So good job. Now, the next thing I'm going to do is I'm going to get cleaned up here. We've got our sample over there, and I'm actually going to prepare that sample for a grain size analysis. Really simple. It's going to tell us about the grain size distribution, and we're going to use the data from that grain size distribution to calculate hydraulic conductivity, which is going to tell us a lot about how quickly water can flow through this aquifer at the Glen Sebastian Nature Trail.